Generator expressions are a cross between comprehensions and generator functions. They use a similar syntax as comprehensions, but they result in the creation of a generator object, which produces the specified sequence lazily. The syntax for generator expressions is very similar to list comprehensions. Expression of item for item in iterable, delimited by parentheses instead of the brackets used for list comprehensions. Generator expressions are useful for situations where you want the lazy evaluation of generators with the declarative concision of comprehensions. For example, this generator expression yields a list of the first 1,000,000 square numbers. At this point, none of the squares have been created. We've just captured the specification of the sequence into a generator object. We can force evaluation of the generator by using it to create a long list. This list obviously consumes a significant chunk of memory, in this case about 40 megabytes for the list object and the integer objects contained therein. Also notice that a generator object is just an iterator, and once run exhaustively in this way will yield no more items. Repeating the previous statement returns an empty list. Generators are single-use objects. Each time we call a generator function, we create a new generator object. To recreate a generator from a generator expression, we must execute the expression itself once more. Let's raise the stakes by computing the sum of the first 10,000,000 squares using the built-in sum function, which accepts an iterable series of numbers. If we were to use a list comprehension, we could expect this to consume around 400 megabytes of memory. Using a generator expression, memory usage will be insignificant. This produces a result in a second or so and uses almost no memory. Looking carefully, you'll see that in this case we didn't supply separate enclosing parentheses for the generator expression in addition to those needed for the sum function call. This elegant ability to have the parentheses used for the function call also serve for the generator expression aids readability. You can include the second set of parentheses if you wish, but it's not required. As with comprehensions, you can include an if clause at the end of the generator expression. Reusing our admittedly inefficient isPrime predicate, we can determine the sum of those integers from the first 1,000 which are prime, like this.